So this is the last video in the neuromuscular junction video series where we will be talking about muscle relaxation. So how does the nerve fiber stop stimulating the muscle? How does the muscle relax and return to its original length? And so in order to discuss muscle relaxation, we're going to need to recap the events that take place during the neuromuscular junction because a muscle relaxes by reversing all of the events that take place. So let's go ahead and start with a summary of events at the neuromuscular junction. So a neuron with its axon terminal or synaptic terminal released acetylcholine chemical messengers into the synaptic cleft via exocytosis, right? And so this acetylcholine is responsible to stimulate the muscle. After this acetylcholine has been received at the membrane by acetylcholine receptors and allowed the entry of sodium ion channels, resulting in an action potential in the muscle, this resulted in the release of calcium from the sarcoplasmic reticulum. We know from the previous video that calcium is very important for muscle contraction because it binds to troponin, which changes in shape and moves tropomyosin to expose these actin sites by which myosin will attach. So once this occurs, now myosin can bind to actin, and this is the cross bridge formation resulting in muscle contraction. So now, how does the muscle relax? So it's pretty much the opposite of these events that I just highlighted. So the first event that will take place during muscle relaxation is that the neuron is going to stop its stimulation. So neuron stimulation stops. So it will no longer excite the muscle. As a consequence of this cessation of neuron stimulation, acetylcholine is also going to stop being released. So acetylcholine release will stop. And this will actually be taken one step further because not only does the neuron stop releasing acetylcholine, but the existing acetylcholine in the synaptic cleft is now going to be degraded. And so this is step number 2, where we have an enzyme that we call acetylcholine esterase. And this is going to break down acetylcholine into acetyl and choline. And so when acetylcholine is no longer active, now it can no longer excite the muscle. Components of acetylcholine, by the way, are recycled back into the neuron to produce more acetylcholine for the next time that the neuron will stimulate this muscle. Now, step number 3. We highlighted that calcium is being released from the sarcoplasmic reticulum to allow muscle contraction. And so during muscle relaxation, calcium ions have to be reabsorbed back into the sarcoplasmic reticulum. So reabsorbed back into the sarcoplasmic reticulum. Now, if calcium is no longer present because its concentration is going to decrease in the muscle, this process will no longer take place. So now calcium is no longer available to bind to troponin. Troponin can no longer move tropomyosin out of the way. And so what's going to happen is that tropomyosin is going to go back to its original location, blocking the myosin binding sites on actin. And this is going to result in myosin no longer being able to interact with actin and result in the sliding filament theory. And so here is our last step of muscle contraction, where tropomyosin will return to block the myosin binding sites on actin. Right? And this is, by the way, just a reminder that this occurs because calcium is no longer present or available to bind to troponin and move tropomyosin out of the way. And so what is this going to result in? Well, now that tropomyosin covers actin, Now myosin can no longer bind to actin. And finally, as a result, no more cross-bridge formation, and so hence no more muscle tension. So the muscle can no longer contract, so it's ended its contraction cycle and it is now entered its relaxation phase.